Hello. Here's a little worked example on some more equilibrium constant stuff this time. An example where they're actually asking you for the equilibrium constant. And it's just a matter of working out what your equilibrium expression is and plugging in some numbers and being very careful that you get the right numbers. So first of all, you've got to get out your expression. So Kc, you know what, shall I make this a bit thinner? I mean, that thinner, that might be better. Let's check that. Kc equals, too thin, let's go there, equals concentration of SO3, that's one of the products, SO3, I really need to do some stuff on this. Now there's 2 moles of them made on the right hand side, so we're going to square that, because it's the same as writing concentration SO3 times concentration SO3, and you're making 2 molecules, so that's why it's doubly important. And then on the bottom you've got concentration of SO2. This is just bloody annoying, isn't it? 2, there we go. Come on, let's try that. I mean, just going to use my mouse. Concentration of SO2, and again there's 2 moles of that on the left hand side, so squared and then times, not plus, times the concentration of O2. But there's only 1 mole of that, so it's just as simple as that. Now it's simply as simple as putting in numbers. Now they've given you concentration even, so you don't even need to do the calculation of concentration, they've given you it. So it is simply concentration of SO3 is 0.920 squared divided by, I mean, let's get it back, it's neater, isn't it? Divided by SO2, which is 0.230, again, squared, don't forget square, times by concentration of O2, which is 1.370 to the power of 1. Now, little hint for if you have some questionable writing or tend to make transcription errors where you write something down wrong and then copy it through, is if you've just written down values that are in the question anyway, just when you look at your calculator, don't copy down what you've written, copy down what's in the question in the first place and kind of scan around like that. So I'm putting 0.92920, I'm going to square that. That gives me a number. I'm going to divide that by, open brackets, 0.230 squared times by 1.370, close those brackets. Boom, gives me a decimal for some reason. Again, fraction for some reason, press SD 3 times or 2 times or whatever to get a value which is 11 point. Well, how many sig figs do they give us? They give us 4 sig figs with O2, but then 3 sig figs with the other 2. So I'm going to go for 3 sig figs, 11.7. And do they want units? Well, I should give units because they haven't said that they don't want units, and I should always give units. But let's pause a second and think about what 11.7 as an answer means. Well, actually, it just means that we have way more SO3 really than SO2 and O2 because the number's a lot bigger than a 1. So we're sitting that equilibrium on the right hand side. Okay, but very quickly so that we get this 100% right, let's go for a different colour pen. Let's go for a spangly pen. And we're going to do the same thing with the units, but actually I'm just going to cheat a little bit with the unit calculation because I've already got Kc in my working out, and maybe I don't think I'm going to get marked for putting that as a line. Maybe this is me taking a bit of a shortcut, but I'm just going to cancel through the SO3 squared and the SO2 squared because they're basically 2 concentrations right there that are both squared, so they can just cancel each other out, and that means I'm left with 1 over a single concentration. So the units are going to be mole to the minus 1 on the bottom, decimeters cubed. So there's units as well. I don't suggest doing that in an exam because they might want to see that first line of working, but you know, it just saves a little bit of time, doesn't it? There you go.